Hello, welcome again with more reports from the EANTC multi-vendor MPLS and SDN interoperability event. We ran the hot staging event in March, as you may have noticed from the previous videos, and we're now releasing a couple of reports with live guided tour demonstrations that we captured back then. Of course, we had hoped to showcase all of this to you live in Paris at the MPLS SDN NFV World Congress from Upper Side later this summer, but unfortunately we just learned that this event has been cancelled. So I'm happy that we have these archives and we can show you all of the results from the hot staging. Now, here besides me, everything is calm and clean and almost all of the equipment has been removed again. During the event, it was bustling activity and all of the 8 racks around me were filled with equipment and with weird cabling and with many people working on this equipment. Now, we are in the process of migrating our events to fully virtualized. Of course, the installation of hardware is still necessary because SDN routers and equipment is not going to be virtualized anytime soon or ever, and there is no good reason to do it in the core of the network and the aggregation, but still it's possible to run many things remotely. So more than half of the participants from this year's event were participating remotely. We only had a few people here installing, racking, stacking, connecting stuff, and we will further improve this ability to run remote events with physical optical layer switches and so on in our lab in the future. So today, without further ado, there will be a demo of the Egress Peer Engineering in SDN EVPN testing, and the demo is run by Rafał Schmidt from Juniper and Victor Vasilescu from Nokia. So over to you guys.
Hello everyone, my name is Rafał Schmidt. I am a networking engineer at Juniper Networks. Today with my colleagues from Nokia and Spirent, we would like to present to you Egress Peer Engineering demo. It's interoperability demo between 4 vendors. Few words about the technology itself. Egress Peer Engineering is currently having a lot of traction in industry because it allows the vendor, or sorry, the service provider in general, to steer the traffic out of the autonomous system based on different criteria, especially on the cost of the bandwidth that is used and with the bandwidth they have to pay for it. So for this demo and generally for Egress Peer Engineering, we are using 2 new routing technologies. One of them is BGPLS, which is providing the information about the topology of the network, and the peering seats, which are transported over BGPLS session to the controller. The second technology which we are using is SRTE, so BGP SRTE. BGP SRTE is using to push the policies, SRTE policies, on the PE router to steer the traffic to the required ASBR peering point. Few words about our topology. So in the current demo we have several devices. Let me start from the left side. So there is a Spirent tester on the left side. Also on the right side, this is the tester is generating the traffic between autonomous systems. Then we have a Nokia SR12. This is PE router, which is steering the traffic towards the required AS system. In this case we have 2 AS systems, 6502 and 6503. We have a controller from Nokia NSP. This is the controller which is steering the PE router Nokia SR12 to the proper autonomous system exit. We have also Juniper MX2046 router, which is ASBR. This router is generating to the topology then information about the peering seats between autonomous system 6501 and 6502 and 03. The purpose of the demo is to show you that based on the controller configuration and based on the current peering seats configuration, we can steer the traffic from the flow from the router which is on the top, which is the Arrcus router 23, to the router on the bottom, which is Arrcus 24. So in this case, these are 2 different autonomous systems, and because of this steering, we can steer the flow to the required autonomous system based on the controller decision. And during the demo, you will see that after the changing the policy from the controller side, which is pushed to Nokia PE router, so SR12, the traffic will flow on the bottom path like it is depicted here by the red line.
I'm Victor Vasilescu from Nokia, and I will show also what we can see from the controller from NSP. So here we can see that we have the Nokia device, and which is connected to the Juniper, the ASBR. And we can also discover all the eBGP links between the Juniper and the Arrcus devices. And here we have two different eBGP peering, which are going to IS 65002 and 65003. I will apply a segment routing policy to steer the traffic from Juniper 103 to the IS autonomous system 65003. And to do this, I have already a segment policy which is configured and which is currently admin down. And what I will do is that I will enable this segment routing policy, and we will see on the Spirent, on the testers, that the traffic is changing of direction. So I'm enabling this policy. And if I display this on the map, I should have this traffic going from Nokia 151 to Juniper 103 and going to the Peer 02, so to the autonomous system 65003. And here I would like to show the results on the Spirent, so to see that we have traffic change on this interface. On the Spirent tester, we are sending some traffic, and we send at the rate of 1,000 packets per second. And right now we have, on the Spirent, we can graph from two different points. So here we are graphing from Arrcus 23, so which is the node on the top of the graph, and which is represented by a blue line. And so what I will do is that I will apply the segment routing policy, and we will see a change here. So I'm doing this right now. So here we see that we don't receive the traffic from Arrcus 23, and now we are receiving the traffic from Arrcus 24. So which means that the policy has been applied, and we have steered successfully the traffic.